What's up, guys? Welcome to another video. This week I just got a cam back from Recore. I had previously shot this one and the results were, they weren't like bad or anything, but I did feel that there was more to be desired. It was also the first time I think on the channel, other than like some coaxial stuff, that I had looked at any sort of cone venting. And, you know, it's not really something I typically do because you can mitigate many of the benefits through varying your clip size and spacing and such. But I am, at this point, more curious in it than I was before. And I want to take another crack at it, basically, with some of the theories that I have from previous experiences and such. So this was the basic cone that I'll be working with, though this will be a mix can, but not in more of the traditional sense that I use a mix can. We basically have a primary angle, a secondary angle, a pocket, and then kind of a third little angle. Most of the work is going to be done by these first two angles. And then we've got this pocket collection area here, right? So imagine the tube wall here. Gas can collect here and then kind of roll off and such. Now, the big thing is that this particular cone will have a vent in the side here. So where this vented gas goes in relation to the next cone in line is going to be one to watch. Also, what our clip depth is here is going to be one to watch in relation to that as well. So here is what that cone basically looks like when you have it vented and clipped and such. So here I have it modeled up with the clip depth that I'm going to end up using, which is deeper than what I had previously used. We've got this vent here on the side. It's about 1/8 of an inch, 0.125 in diameter. It's on the lower portion of the cone, so it will actually vent typically below, depending on the spacing used, the rim of the next cone. We're going to look at that here a little bit more, but you get the basic idea. As far as like the angles and stuff go, we've got, we'll just go ahead and kind of draw them out here for you, but this is 90 degrees and 90 is 0 when talking about an included angle. So in this case, if we go out to here, 115 subtract 90, that's 25. So our 25 times 25 is 50, so we have a 50-degree primary angle up here. And then for our second angle, we've got, what's that? Basically, if I can get this stupid cursor to kind of work here, there we go. 133, so you would subtract 90 from 133. It's a little odd that that's an odd number. Again, I'm having to kind of go back and model these from before. But if you subtracted 90 from that, we would have 43. You would multiply that by 2. So that's 86. So we're probably either like an 85 or a 90-degree angle here in reality. So, I mean, it might be off just a little touch like that right there. But that said, after that, you've got the pocket like we've talked about. And then this third angle, while it is technically an angle, it's not acute enough to really be doing much more than what it would be if it was just flat here, to be honest with you. We do like having that angle there because it does help allow like our clip gas to kind of get more underneath here in this area, whereas opposed if it was kind of flat there, I mean, you could bring the pocket down more, right, to make it flat, and then you'd kind of have a little bit more trouble getting into this corner area here. So there is some benefit to having that angle there, but not so much for flow on the front portion of the cone, in my opinion. So you're probably wondering what is different this time around. So far, nothing has really changed. I'm just giving you kind of some background on the cone itself. And here's where things start to get a little bit different. Before, it was all This can had all just these cones in it, and they were all vented. So that meant the blast baffle had that vent in it. The distal baffle had that vent in it. Now, I, for one, think that I'm not really that big of a fan of venting the first cone, and I'm also not a huge fan of venting the last cone. And why is that? Well, the flow, the venting the first cone can kind of cause a delay, and also can kind of end up hurting first round pop. And then venting the last cone, or even if we didn't vent, let's say the last 2 to 3 cones, can help. I mean, that initial flow into the can, the venting will help that initial flow in the can. But then we also, we need to control how quickly that flow then exits the can as well. So by changing the conage and the venting of it, we can actually do quite a bit to find a balance there. I don't know how many people might remember like my old mushroom style cone stuff that I had, but if you are someone who's been around for a while and have been watching things that I've built, you'll remember that I would only waist clip about roughly half of those cones. Also, the MJR style, which was like a radial with like a coaxial pocket thing, same kind of deal. Found that venting everything was just not a total net benefit, where not venting some of the distal helped control the overall flow of the can. Now, the other thing here is you'll notice that I have a single step 50 modeled up. And, I mean, I'm getting the thing record, right? So I might as well have a better first primary cone, especially since I'm not going to be doing any venting. So that is my plan here, to have a single step 50, followed by these more, I haven't really given these like a catchy name yet, but for now, this is what at least the first 2 cones are looking like. Now, the third thing I want to do on this particular guy is I want to use clip sizes more in line with what my current thinking is, and that is that while you can obviously clip the entire can one depth or width or both, I'm, especially when you start mixing geometry and some bigger spacing and some smaller spacing, am more of a proponent at this point of variable clip sizes. It kind of depends though, but at least for the first cone here, I've got a ton of room between these 2 cones, so I can do some pretty crazy stuff with my clip size here. So I also, of course, am looking, especially with the venting on these cones, I'm really hoping to see better 5.56 numbers. That's kind of my goal with this can, even though this has a 30 caliber bore. I'm hoping that I can get some better than typical that what we've been seeing 5.56 results. So far, the best 2 5.56 cans on the channel, or I should say cans that get the best 5.56 numbers, are typically Pocket Cone version 2 and the LN can. Neither of which are like crazy great on 5.56. The Pocket Cone version 2, especially once you get past first round pop, does pretty well. Now, if we were to have gone back and maybe used 5.56 bores on those, they might be better, and they could even be worse because of additional back pressure, which then you could go and maybe do what we're kind of doing here, and that is venting some additional cones to change that metric. All right, so we're going to see just how we can vary some things. So my plan is, especially in the beginning, even though, and especially since I'm not venting the first cone, is to use a bit deeper clip on this first cone instead. So this is kind of what I modeled up, that a 265 to a 270 deep clip for at least this first cone is completely possible. It would get us flow underneath the furthest portion of the first cone at that depth. Now, it does also open up this bore here a little bit more than typical, than like a 200, which would be somewhere up in here. This is also going to then what? Change the back pressure metric and the flow into the can. And it's going to delay the time before the back pressure builds, right? It's going to take longer amount of time, especially with those vents in those secondary cones after this primary first cone, until it reaches that non-vented last cone and then can start fully pressurizing the rest of the way. By that point, the bolt might have already cycled, or at least be in a part of the S-curve that is a little bit less pressurized, and possibly give us some better at-ear numbers. This is all theoretical here at this point until we actually test it. But that is so far my plan. One of the next things I did was I modeled up the cones and kind of looked and tried to figure out what the absolute smallest chamber I could use was. Now, if I kind of just read these off here left to right, we've got a 400, a 450, a 550, and a 675, and then a basic 0.5 here at the bottom spaced. My goal was to find what was the deepest I could clip and the closest I could bring the cones to kind of together. Now, I basically found that 400 was about too much, and that 450 roughly was probably about the tightest I wanted to go. If you look closely at 400 here, I've got a line for my 200 depth of clip, and then I've got a line for a 240. You'll notice that both of these bottom lines do intersect the tip of the next cone at only 0.4. And then you also have to imagine where that vented gas is on the side. Now in this case, it's well below the tip line here, so it's not really an issue. Do keep in mind that the vent will be directly underneath the clip opening. So that vent on the side will actually be over here in relation to our clip here. So this is a no-go for me, right? I don't want to be cutting off any of this part here. Now, if it was only like one cone at the very end that was this chamber this small, I mean, I'm fine with that, but I don't necessarily need to probably do anything this tight. So going up a step to 0.45, it gets me to this guy here. Now, my goal is to use, in general, a little bit deeper clip on this guy. Again, because I'm really looking to get a fairly high pass-through rate on this can, but doing it in ways that will still give me good suppression. Which is why I'm focusing more on clip than looking at like trying to make larger vents or more vents or anything like that. I'm looking for a very specific balance here. So, at point 240, so that clip is anywhere from 20 to 40 thou deeper than what is probably typical. It's not, some people would say a quarter inch, a 250 clip is a very, very big clip. You would see like on the Dead Air Sandman, for instance, you would see like a 250 by 250. I don't like how aggressive that width is. If I did need to go wider in width, I'd go more to like a 0.25, like a 0.225, something like that. But at 240 deep, I can space as small as 0.45 here and clear my tip here. Now, we do come into contact with this area here. Not much I can do about that. That is just the geometry of this cone. Of course, this also kind of highlights where like a 3-angled cone becomes sort of a benefit. And that's why you see a lot of 3-angle stuff kind of becoming the rage, or dual angles that are just kind of half interceding these two. And that's because you can get down in this bottom area a little bit easier. Now, of course, if there was more space between these two cones, that wouldn't really be an issue either. In this case, I actually kind of like how this was done, though I would have probably made this angle over here a little bit more acute. So I would have probably, if I should say, looking back on it, taken it from like here to maybe like right up to there. While that's such a small change, it will have an effect. I know that for a fact. Now, that I've addressed what my smallest chamber is, I'll just go ahead and kind of show you guys what some of the larger chambers look like for reference, basically. So here you've got 550 and then all the way up to 675, which is typically about the biggest chamber I really like to use in most of my rifle cans, especially lately. I know there's 0.7s and 0.75s, but I've kind of been getting away from those bigger chambers. But you'll even notice with a 240 deep clip here, we're still kind of hitting the side here. But I'm not really that worried about it. It will still deflect and be lower than the tip of the bore, right? If we go all the way up to like 675, potentially you could go to like a crazy deep clip. But by that point, you've opened up this bore so much, you're probably negating any benefit you would have there by doing any of that. But it is something you could do if you had a lot of back pressure and needed to bleed some off. But that said, this is just more or less showing you what the larger chambers will look like when they're stacked. So now I want to go over what was the spacing previously in this guy before sending it off to have it record. Like I said, it was all just the one style of cone that we're talking about. It had a pretty big blast chamber. When we include the rear end atlas here and that 1/4 inch of back bore on the rear end atlas, we had over about 2.8 inches of blast chamber. So a lot of distance and time between here and this corner. Now again, every single cone had a vent in it. All right. And it more or less got results very close to the single step 50 can that had spacing pretty much the same way. Now, I had a 0.7, I mean, these are like the exact numbers that it ended up coming kind of to. But the goal, for instance, on my first chamber was 725, and it came along. So it was like 725, 65, 6, 5.5, 5, 4.5, 4.5, and then you see this 0.407. So after the fact now, talking about this like we just had, this 407 probably shouldn't have ran anything that tight in this case. I probably should have stoled from, like this chamber here, or these two chambers here a little tiny bit to get this up to that 450 mark. But that is why we have FFLs that can do recores, right? They can fix our mistakes. And like I said, the can did well. It did, and it definitely did well on 5.56. But I feel like there's still some to be gained out of the sky. And I didn't really like how big this blast chamber ended up being either. A little bit of wasted volume there, in my opinion. So now basically this is what I have gotten back. So here we have what I want to be testing this week. I sent a schematic and of course had the changes made. And I came up with that I wanted bigger spacing in the back, because when watching the channel this year, you'll have probably figured out by now that my style of building cans has kind of changed over the last 6 to 12 months, and that's the whole point of what I'm doing. I'm testing things and I'm constantly evolving. All right. Now, I'm sacrificing some of the blast chamber that I normally would run. Normally I would run a 2.5 here. I'm going to go ahead and run a 2.3. So I'm going to take 2/10 because I feel like it'll give me more benefits used in the stack. It's still above my my minimum that I like, which is 2.25. Okay, so I'm still 50 thou above that. With my rear end atlas here, and especially because the muzzle devices and why I love it are fairly short, I'll still have a nice bit of distance here between my muzzle device and my tip. You have to remember, it takes the gas coming out of your barrel a little bit of time for it to really start to spread apart. It will stay very laminar in this first part of the can, okay? And then you're trying to catch at least this first major pressure wave. You're trying to give enough volume here too that you're not dumping any sort of crazy amount of pressure into a small chamber. But it still takes a while for this gas to really start to spread apart. And that's one of the reasons why the middle of the can, or at least kind of this first area here, tends to get to be the hottest, because that's where the gas really starts to expand into these actual chambers. It's another reason why we want some volume in these first few chambers, but nothing too crazy either, because we do need cups and clips to get it to come off this center line here. So trying to find the best balance is always what the goal basically ends up being here. Now, as far as the rest of the stack goes, I've chosen to keep the distal cones static and a little bit further apart than what might be typical. You can imagine the side vents here. I kind of wanted it to vent above the tip of the next cone and not down here pressurizing this next chamber. So my theory is that the gas venting here, and then the gas kind of doing this number 2, and then you've got your clip gas kind of doing this number 2. Actually, it would be coming from, let me redraw that. So you'd have your primary gas splitting off. You'd have the clip gas kind of coming across like this. Then we'd have, let's do it in blue, our vent over here below the clip, kind of venting gas like this. And then we'd have our primary flow down the center kind of coming to, getting pushed off to the side by our clip. And then possibly this pressure coming through here or whatnot might help also press some of this flow off to the side. So that's kind of also why I chose such large chambers, because it would get this tip kind of out of the way of where my vent hole was. If I wasn't so worried about all of that, or I had a different theory for that instance, I might have gone with something more in line like 450 to 0.5, which was kind of, again, what my minimum sort of was. Also at this 575, my deeper clip that I plan on using on all these has plenty of room here for these side chambers as well. Now the next thing you'll notice is that the last cone is also a single step 50. And that is because did not want any venting in through that last cone. Also, you can see kind of here, if you kind of look closely, but it looks nice when it's stacked behind all these. We gain all this nice big chamber here for our last area. So there's a time component to all this, especially in the distal end. The gas is slowing down. It's not as dense at this point. And this little bit extra volume here, especially before we go and vent into our distal chamber and then out the front, could be a nice little feature to have. And then couple that with the lack of a vent. This is the area that will start then pressurizing, and as this builds positive pressure here, that will then what? Force the pressures here, here, here up a little bit higher. But by this point, it's taken place so far down in line in the can that it's changed the entire back pressure metric of the can, or the characteristics of it all, right? I have used fairly minimal distal on this guy. There's about 1/10 of an inch of cone here. Half of that's going to be, for the thickness of the rim there on the last guy, and then a little bit of skirt there. So with the back bore on the cap, we're right around 4/10 of an inch of distal volume in this particular area here. Okay. That's above kind of my typical minimum that I shoot for, which is about 375. Again, I would even be happy with 375 at this point. I think the volume, instead of a 0.5 here at the end, is better used in the stack like I had planned. So that's basically how this thing is turned out. So just to kind of summarize everything before we wrap this up, I'm just going to to give you kind of the conclusion here. And that is that we've got 675, 675, 656, 575, 575, 575, 575, and roughly a 0.4-ish distal. We've got an unvented first cone, which is a single step 50, followed by these multi-angled cones that are all vented an eighth of an inch on the side directly underneath their clips, with another single step 50 unclipped as the last cone. As far as clip depths go, this was a 265. These are all 240s, all the way to the very last cone. Again, the vents are directly below the clips. And that basically sums this one all up. I'm very eager to find out how this one does. I have some fairly high hopes for it. So if it does miss the mark, I am going to be pretty disappointed because I've been waiting to get this one back for quite some time. But I'm hopeful, and the data will speak for itself. I'm most hopeful to see if we get good 556 numbers, and if we can get good 308 numbers too, that would be super. I'm not sure how it's going to do on 300 blackout with the venting and all that. Could even get surprised there too. It's to be determined at this point. We do know that the lower pressure stuff does seem to like the single step 50. The single step 50 does very well in 300 blackout subs. Typically, it's actually one of the best guys I've got in that arena. We know the single step 50 handles first round pop very well, so hopefully that can give me some good benefits here too. I'm really super hopeful that we've got a really good balance here, and who knows, maybe we can knock something off of the first place podium this weekend, but we'll see. All right, guys. Well, thank you for tuning in. I appreciate your time, and we'll see you guys Friday to go over the data on this one.